My good friends out there, good day. I still remain your lecturer on chemistry. Dr. D.A. June is my name. Our previous lecture, we talked about how to write a chemical equation. And if you are following that lectures, you know what and what parameters you ought to know as a chemistry student before you go ahead to write a chemical equation. But right away, we want to discuss the topic titled How to Balance a Chemical Equation. If you are a chemistry student and you have succeeded in writing a chemical equation, if you don't balance it, you have not written any equation. That is the blank truth of it. So not until you are able to balance an equation, that equation is never an equation. So, and then to have a balanced equation, you must have certain rules and regulations that you must imbibe with. Now, what is balancing an equation mean? What is the meaning of balancing an equation? See what I have here on my note for you. Balancing a chemical equation means that the number of atoms of elements at the reactant side must be equal or must be the same to the number of atoms of the same element at the product side. Let me take it again. Balancing of an equation means that the number of atoms of elements at the reactant side must be equal or must be the same to the number of atoms of the same elements at the product side. In any chemical equation, you have the reactant and the products. Let me give an example. This nitrogen, maybe hydrogen, and this gives you ammonia. So let me just balance it first so that we can now react to it. So now this side is called the reactant, while this side is called the product. So balancing equation is saying that the number of atoms of each element on the side of the reactant must be equal to the number of atoms of that same element at the product side. That is the meaning of balancing equation. All right. Now, before you can successfully balance a chemical equation, you are required to, one, know the correct chemical symbols of the elements or the atoms that are participating in the reaction. For example, if sodium is participating in a given reaction, or if chlorine is participating in a given reaction, you must be able to know the chemical symbol for chlorine and that of hydrogen and that of sodium and that of any other element. You see, now for example, sodium is written Na, not Na, not Na. Then chlorine is written Cl and not Cl. Can you see it? If you write Na as a symbol of sodium, you are wrong. If you are writing Cl for that of chlorine, you are wrong. So sodium is capital N, small a. Chlorine, capital C, small l. So these are the correct symbols for this element. If you are writing the chemical equation or to balance an equation, you must know the correct chemical symbols for the elements that are about reacting. Very, very important. Number two, you must know and be sure of the products that will be formed. For instance, if chlorine and sodium are participating in the reaction, you have known the reactant now. Now, what will be the product of this reaction? You must know it. So not until you know the product of the reaction, you cannot get a balanced equation. Now, the number 4, you must also know the states of the reactants and the products, whether they are in the solid state, or in the liquid state, or in the gaseous state. So when elements are combining, what state are they when they are combining? And when they are forming products, what are the states of the products? Are they all in gaseous state? Or are they all in liquid state? Or are they all in a solid state? This is also very important. Now, for example, now, assuming now that we have sodium reacting with chlorine. Now, let's take this example to give you sodium chloride. Sodium as a metal here is a solid. Chlorine, a gas. And then here, it's a solid. See now? This is the gaseous state. This is solid state. They are doing with the gas. The product is what? Solid. Now, Cl is always written Cl2. That is chlorine when you're reacting. So here will be now Cl2, though in the gaseous state. So now when this equation is formed like this, you're not seeing that at this side of it, chlorine is appearing only 1, while it is 2 here. Here, sodium is 1, sodium is 1. So to balance this equation, you start from the lowest. So if you put 2 here, this 2 becomes what? A coefficient, and is a multiplier of everything here. So by these 2, you have made sodium 2. Sodium here is 1, so you put 2 here also to balance. Oh, we'll get there. Then also, number 5, you must know and be sure that the chemical formulas of the chemical compounds that take part in the reaction. I take it again. Number 5, you must know and be sure of the chemical formulas of the chemical compounds that are taking part in a reaction. For example, if an acid and a base are reacting, or acid and other things are reacting, how do you know the chemical symbols of the compounds that are reacting? Very important. For instance, now, if H2SO4 is an acid reacting with sodium sulfate, maybe Na2SO4. See, this is called sodium tetraoctosulfate 6. This is called tetraoctosulfate 6 acid. If these two are the ones combining, these are already compounds. Your ability to know the chemical symbol or the formulas of this is very important, because if you don't know them, you cannot react them. Even if you react to them, you don't know how many products are formed. And without knowing the correct product, you won't be able to balance the equation. So, how to balance the chemical equation is very, very important. So now, the duster. Now let us see. Let's see. So next time in our next lecture, we will talk of the principles of balancing a chemical equation. For now, please subscribe to get more of lectures. Thank you.